Hi, I'm an old guy and I do maths, and you will have noticed that we do a lot of differentiation on this channel. In fact, we do a lot of calculus. And the reason for that is that it's a big area and there are many ways in which expressions have to be differentiated, and generally speaking, there's just a lot to learn. So today we're looking at how we differentiate the surd expression. And the first thing that we have to do is we have to get it into a form in which we can differentiate it, which means that we have to put it in index form. And those of you who have questions about how I get from here to here should probably have a look at some of my videos on converting surds to indices and vice versa. But just very quickly, this is the fifth root of this expression. And a fifth root using indices can be written as 1 over 5. This is the root, this is the power. So this is the fifth root of this expression to the power of 1. Something to the power of 1 is just itself. Okay, now, having got it in this form, we can see that we're going to have to use the chain rule to differentiate this. And again, I would refer you to my videos on the chain rule and how it works if what you're about to see is somewhat confusing. But dy dx is going to equal the differential of this expression, u, which is 1 over 5 x squared plus 2x. We're going to subtract 1 from this, which is going to give us negative 4 on 5, times the differential of what's inside this bracket, which is x squared plus 2x, which differentiates to 2x plus 2. 2x plus 2. Now, this, technically speaking, is the differential of this. However, there's an old rule, some call it an annoying rule. It's more, maybe not a rule is maybe the wrong word, but it's considered stylish or polite if you're asked a question in one form to answer it in that form. Now, we've been asked this question in surd form. We've got an answer here that is in index form, and we're going to do something about that. Okay, so let's deal with this expression here. This is 1 over 5. So that's 1 over 5. This is a negative index, and it's got a root and a power. So we're going to write that down here. So it is the fifth root of x squared plus 2x to the power of 4. Now, if we just leave that aside and forget the 1, or rather forget this 5, this expression here is simply the fifth root of x squared plus 2x to the power of negative 4, which means that we would create a fraction with it, 1 over that, and we get to this point. Now, this is all times 2x plus 2. So we can tidy this up a little more. And what we get is, we get 1 over 5, that's this, times 2x plus 2 all over the fifth root of x squared plus 2x to the power of 4. We can probably tidy that up a little more. 2x plus 2 all over 5 root 5 x squared plus 2x to the power of 4. Okay, I hope that you were able to follow that. As you can see, to some extent, the easy part of it is getting the differential. There was actually more work in converting this differential back into surd form. But this is our answer. If you want to, just roll this video back and watch that process. Anyway, thank you for watching. I hope you found it useful. If you did, please like and subscribe, and I'll see you next time. Bye.